2 Tests, hallo, herzlich willkommen zum Automatikforum. Ja, okay, gut. Perfekt. Ja, so, willkommen zurück zum Automatica-Forum. Wir machen weiter nach dem Roundtable jetzt weiter im Programm und wir machen weiter mit dem Thema Bildverarbeitung. Genauer gesagt mit The Next Level, Guide to Camera-Based Automation von der Firma IDS. Und da wird Martin Hennemann von der Firma IDS, Produktmanager 3D und Vision Software, jetzt über das ganze Thema Camera-Based Automation sprechen. Bitte schön.
Thank you. So, hello everybody, welcome to Automatica Forum, welcome to our session. I'm Martin Hennemann, working at IDS in product management, and what I'm going to want to show you today is about our motto, it's so easy. So I want to bring to you the next level of making camera-based automation easy and convey a number of ideas that we and others follow to do the next generation of machine vision. So let me quickly introduce IDS. This is our new headquarter building. We are close to Heilbronn. That's about 300 kilometers west from here. IDS is a major supplier of industrial cameras. In our portfolio, we started with 2D cameras. We added 3D cameras, and also in the last several years, an AI-based vision system. Some numbers about IDS. I mentioned 300 kilometers from here. We have about 2 million cameras in use worldwide. And on the right-hand side, more than 350 people employed at IDS. I have 3 main parts of my talk today. So I want to first introduce what is easy vision. And with that I mean, what are easy vision tasks or complex vision tasks, and how can we make the complex ones more easy? Then I will go to easy learning, because that will play a huge role in employing new technologies for machine vision. And at the end, I will finish with easy automation. So from our side, what can we do? How can we make implementing machine vision systems easier? So a very short introduction on machine vision. What is vision about? To put it very general, it's about image acquisition. So machine vision always has to do with images, so we start with that. Next step is we use the images to extract some features, some information, and then ideally we should make a decision or convey some information that we have gathered. Now, I want to use a situation that you know from everyday life to illustrate a bit simple and complex vision tasks. So we look at the grocery checkout process, and the way this has been automated in the last decades, you all know. So this is barcode reading. So this approach was very useful in basically making this process smoother for all of us, enable supermarket cashiers and so on. But you have to prepare for that. The whole world has to print barcodes on their products, and then you can basically have this automated. So by now, this is a rather simple vision task. Here there is an illustration how that works. We try to have defined imaging conditions. Nevertheless, you know that sometimes the first scan fails, but you can do it a second time. The encoding of the information is clear, is well defined, so you need some math to do it because you will not be able to do it in your head. Nevertheless, it's completely solvable. However, as said, the usability of this kind of vision process is limited because, as mentioned, the whole world has to be prepared to support that. Yeah? So what others and we are working on is another step in this everyday process. That's about product recognition. So what if we don't have to prepare every product for the scanning process, but we look at this and in practice, this has some advantages because you don't have to touch the products at least twice to pull them over a scanner and so on and so forth. So I would call this product recognition. However, this is now a complex vision task. We have variable imaging conditions, so we don't know in which situation a product will be seen. The processing, how to extract the information from the image, is unclear. It's a whole new challenge to solve. For the barcode, it's very clear. However, if that would be solved, if we had a system that does this, product recognition, automizes this, it would be, of course, extremely flexible to use in practice. So, and in this area, of course, the technologies that were developed in the last years, so deep learning or AI technologies, will help. What do we have to do, or what will they bring us? They will all work by learning from images. So instead of thinking about how to encode, let's say, a numerical product ID into a barcode so that I can decode it again, it's about providing image features and learning image features. And so we will enable flexible operating conditions while using these technologies. I've tried to visualize here a few examples, especially the one with natural products like fruits. We already have the requirement that these imaging and operating conditions, they vary a lot. They are outside. And however, if we have these technologies now at hand, this is also a way to lower the technical barrier to develop these applications, because the focus for the, let's say, the implementation of a solution based on these technologies will shift from learning algorithms to working with image data sets. So we are working on providing technologies where you basically put in images and show the system what you want it to do, what you want it to see, to recognize, and it will basically solve the task for you. So this is already a first part of my presentation, and now I like to go a bit more deeper into how can you now make this introduction of these new technologies easier. How do you want these systems to learn? So I want to show you two ideas that others and we are looking at and are developing. So one is show what you want to teach. So essentially you want a system that you can train by just teaching. Yeah? You show the system what you want to learn. And the second idea I want to show you, it's a technology demonstration. That is, so if the system needs quite, let's say, well-defined information translated to labeling, so you have an image where you need to give the system concrete information on every pixel in the image, that this is an object, this is another object. How can actually these technologies already help in this process, because that's very labor intensive. So first is show what you want to teach. This is one of our tools that we introduced. This is code reading again, so it's a rather simple vision task. But the point here is you want to have two. Oh, sorry. I think I need a click to start this video now. So maybe, yeah, thanks. So what we see here is this is a code reader. It shall read data matrix codes. There are two on this camera board here. And what you want to do is to have a button like we have here, just to look at the image and tell me what codes are on there. And then if I want, I can parameterize this a bit further on what exactly I want the system to have. And now we are already done, because the system recognizes the two data matrix codes, can read them out, and it also works on the next image, which has a little bit of saturation in it. So this is one approach that we are working on. You have a system and you show it the information you want it to give you, and you have one button to detect and optimize. The next idea, second idea, now we have looked again at the simple vision tasks of code reading, code detecting and reading. Now, what about this? So, what about this situation? How can I basically learn or give the system information from these kind of images to learn the different objects? So here, let's see if that will run. Yes, I think it starts running now. Here is a technology. Sorry, yeah, it's running, sorry. So here's a technology demonstration with new algorithms. Some codes have been published this year, where actually the AI assists to select regions in the image that belong together. So there is some knowledge behind it, which objects, which pixels belong to one object. And as you can see here, by defining one or two, or doing only one or two clicks, actually the selection will include a useful object, like the whole tomato, or in this example now, the human skin, and all of it in the image. So there's a lot of knowledge already inside this AI, and this assists us to produce the kind of data we need to train the systems we want to have in the end. Here's another example from a store. The first one was just a package. Here you click on the label and it selects only the label. You do a second click and it will learn that you want a whole package to be selected. And that's almost pixel precise. Here, a stock photo, there's a foreground object. You put 2 clicks on there and you select the foreground pixels to separate it from the useful background, let's say, or one of the boxes. So that's kind of what is now becoming possible by these more generalized models that know what an object is already in the world. Now we come to more, let's say, machine vision use cases that we have, like recognizing individual objects on a varying background. And this is just demonstrating that you can get either a box around the object or you can get it pixel precise selected in these cases. And I especially like the last one because they show some added functionality here. This application is only about recognizing and counting these metal surfaces, these rings. And here you can see that in this example it doesn't work well. It will select the whole thing, not only the ring, but then you have negative points. So with this technology, you can actually tell it what not to select. And this is done now, and you can see you have almost perfect, not quite perfect, but again, a nice selection of the object that is interesting. And this is, as said, technology just developed in the last months to help us build these systems for complex vision tasks, like training all the fruits, all the vegetables, all the packages that we want to have. So, and now going towards the implementation of machine vision. So, since I think already 2 decades or so, the low-code approaches and no-code approaches have been developed for writing software. We have done steps in that direction. So what you want to do is you want to visually build decision logic step by step. You want to have the systems to be able or to support you by inspecting and adapting. So you basically do not set things that have to work in stone and then test it like on the next day and then come back the next day and change it. You want to have a very fast cycle of inspecting the results you get and adapting that again. And of course, you have all the automation prerequisites that you have to serve, some outputs and some industrial interfaces. And one approach that we and others follow in the last years is that there are visual programming languages. It was mentioned earlier for robotics since a while. You have things like Blockly, Scratch, or Snap that now, since a few years, are actually used to teach our kids how to program, and particularly program robots. That's usually a nice connection there. So what you do there is you drag and drop blocks, and these blocks represent some code snippets. And when you have your program assembled and it works, you can basically just create the syntactically correct code in a chosen language. And I want to go through one simple example of what is possible with our vision system here. So this is just a counting application. We want to validate whether all these pill areas are filled correctly, and if not, we want to signify that. So the result of this machine vision task should be like this. Here in this case, all are present, all fine, and in this case, 2 are absent, so I want to have an information that pills are absent. So again, rather simple vision task tackled with a deep learning approach. So what do we need as ingredients in the program? We need to find the object. So ROI here means region of interest, not return on invest, but region of interest. We want to classify for each ROI present versus absent. That's the deep learning part. We want to validate the number, and we want to give some signal or some actuation if we find something incorrect. And this is how this would be realized in our Blockly implementation. So this looks still a bit like too much, like too many blocks. You can reduce that, but every reduction that you do here, of course, makes it a bit harder to learn. So that's why I'll use this. You can see on the top that we have the ROIs defined one by one in this case. We have a classification that is all done in this orange block here. And then at the end, we just check for each ROI and with some if, so decide what if there is absent or present. And in the end, we set a digital I/O to some level, and a control can recognize the situation from there. So that's what we have as another idea of making things easier. A second example, that's about localization. So here, simple, we want to find specific objects and then give some information of the object, like the position, to some receiver. And that would be in its simplest form like this. So again, there is some initialization, and then there's one step of detecting it using AI, and then we send some, in this case, HTTP request post to some receiver. So that's the idea of making the logic of the application easier or more approachable also for non-software developers. And then, so this is the last video I want to show you. It's about inspecting and adapting this. So if I press that now, I hope it will start running. It does. So this is just quickly showing how to assemble this program, but also how to give feedback while developing this. So inspection and adaptation means in this case you will go through sequences of run, set a breakpoint somewhere, and then step through your logic and see the changes. So now the mouse pointer has just went on the play, put breakpoint, and then you step through your logic and you fiddle around with it, you improve it. And that's what I mean, that our users want to have quick feedback and be able to have that during development. Yeah, and with this, I have presented you the ideas I wanted to show. More interest can be satisfied at our booth in the opposite hall here. And I want to thank you for your attention.
Ja, vielen Dank, Herr Hennemann.